Hello students, so today we are going to start the topic application of derivatives. Okay, so here we'll learn the rate of change of quantities. Okay, so rate of change of quantities with respect to time. Okay, so if you have in this chapter you will need all the areas. Okay, area related to circle, area related to cube or a cone, cylinder, and also you'll need volume. Okay, so area of a circle, just go through all the things. Okay, so I will write here about circle. Okay, radius is r, so area is pi r square. Its circumference is 2 pi r, right? Circumference means the outer boundary. Then if you have, say, cylinder. Okay, so cylinder, it has two areas, that is a curved surface area and a curved means this part. Okay, and total surface area. So curved surface area is 2 pi r h, and total surface area you have to just add these two circles. Okay, these two areas of these two circles, so 2 pi r h plus pi r square. And its volume. Okay, so volume is like you are keeping these circles on each other, okay, for h times. So the volume will be what? Area of circle into h times you are keeping it, so pi r square h. Okay, cone is like this. Okay, this height is h and this height is slant height. Okay, so its curved surface area is pi r l. Okay, total surface area will be addition of this circle, that is area of this circle, so pi r l plus pi r square. Okay, and this thing, volume is 1/3 of cylinder, so 1/3 of volume of cylinder. Okay, how to find L? You have to use Pythagoras, so L is h square plus r square. Okay, so we'll need this. Let's see one example. Find the rate of change of area of a circle per second with respect to its radius, where r is 5 centimeter. Okay, so the area of a circle is changing with respect to its radius. So the area of a circle is changing with respect to its radius. Okay, what is the area of a circle? It's pi r square, right? So you have to derivate with respect to r. Pi you can keep outside. Derivation of r square will be 2r. Okay, so it is 2 pi r. Now here the radius is given, that is 5 centimeter. Okay, so the value of area changing with respect to r, you can write here r equal to 5 is 2 pi into 5, that is 10 pi. Okay, now this is your area changing with respect to r. So the area of the circle is changing at the rate they have asked for per second. Okay, so this area is changing with 10 pi. Now this radius was given centimeter, so this will be centimeter square per second. For 1 second it is changing like this. Okay, centimeter square. Okay, so next question is, volume of the cube is increasing at a rate of 9 cubic centimeters per second. How fast is the surface area increasing when the length of an edge is 10 centimeters? Okay, the first thing which is given is volume of a cube is increasing at a rate of 9 cubic centimeters per second. So volume of a cube, how it is written? Cube is like this, right? All sides are equal. So volume is given by, suppose this is the side and this is also the side, this is also the side. So when you keep this area of this part will be a square, right? And it is for a times. So volume is a cube. Okay, volume is given by a cube. So here it is given that rate of 9 cubic centimeters per second. So with respect to time it is changing. So your volume is changing with respect to time. Okay. Now the volume is given. What is the value? It is 9 cubic centimeters per second. So 9 centimeter cube per second. So your volume is given 9. Okay. So you can write here d by dt of a cube. Okay. But the problem here is you are derivating with respect to t. Okay. So here you have to derivate. So this will be you have to derivate also a. Okay. So a will be what? D by dA of this a cube into derivative of a, that is dA by dt with respect to t. Okay. So this will be 3a square dA by dt. Okay. So this is 9. So this 3 you can take here. So this will be 3 equal to a square upon dA by dt. Okay. So you can take this a square also here. So 3 upon a square equal to dA by dt. Now second thing which is given is how fast is the surface area increasing when the length of an edge is 10 centimeter. So you have to take the formula of surface area. Now here what is the total surface area of cube? Since there are 6 faces, okay, all the faces are square, right? So area of one face is a square. So area of 6 faces will be 6a square. So your surface area is changing with respect to time, and surface area is 6a square. Again you have to derivate the way we have done here. Okay, both you have to derivate a also and with respect to t. So this will be d by dA of 6a square into dA by dt. Okay. So this will be 6 into 2. So 12a into dA by dt you can take from here, that is 3 upon a square. So this and this gets cancelled. This is 36 by a. Okay. Yeah. This is your surface area. And then they have given how fast is the surface area increasing when the length of an edge is 10 centimeter. So length of the edge is given, that is the side is given, that is a is given 10 centimeter. Okay, you can substitute here. So this will be 36 by 10, which is 3.6. So your surface area is changing with the rate 3.6 centimeter square. Now it is area, so centimeter square per second. Okay. Third question is, a stone is dropped into a quiet lake and waves move in a circle at a speed of 4 centimeter per second. At the instant when the radius of the circular wave is 10 centimeter, how fast is the enclosed area increasing? So the stone is dropped into the water. So here the circles are forming. Okay, so this will get bigger and bigger, right? So the this radius is increasing. Okay, now speed moves in a circle at a speed of 4 centimeter per second. So speed is given. What is speed? Speed is distance upon time, right? So speed is given, that is 4 centimeter per second. 4 centimeter per second. Yeah. So sorry. So this is distance upon time. So your distance is increasing with time. So this is increase in distance. What is increasing here? Here it is radius. Radius is increasing. So speed you can write dr by dt. That is rate of change of radius with respect to time. Right. So this is your 4. And here the area is increasing. Since it is forming circles, the area is increasing with time. So this area dA by dt. Okay, so what is the area of a circle? Area of a circle is pi r square, right? So again you have to derivate both the terms t and r. Okay, so pi you can take outside. So first will be derivation with respect to r square, and then dr by dt. So this will be into 2r dr by dt. Now since dr by dt is given, that is rate of change of radius with respect to time, which is our speed. So I can substitute here 4. So this will be 8 pi r. Okay, and then they have given when the radius of the circular wave is 10 centimeter. So radius of the circular wave is 10 centimeter. So you can write here 10. So this will be 80 pi. Okay, so this is the area is increasing at the rate of 80 pi centimeter square per second. Okay, these 3 examples are there in the textbook. Okay, these are solved examples. We'll do some unsolved examples also.